Question 13. Aqueous NaBH4 reduces aldehydes but does not reduce alkenes. Show the first step of the mechanism of reaction between NaBH4 and 2-methyl-butanol. You should include two curly arrows, and then explain why NaBH4 reduces 2-methyl-butanol but has no reaction with 2-methyl-butanol. So, first step of the mechanism, let's draw out 2-methyl-butanol. Probably the hardest step, because you either know the mechanism or not, and if you know the mechanism, the hardest step is drawing out the molecule, and then you already know where the curly arrows should go because you know the mechanism off by heart. So 2-methyl-butanol, so we've got butanol, methane, ethane, propane, butane. So we're going to have C, 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 C. This is al, so aldehyde. We're going to have a double bond O and a H. We know there's a methyl group on the second carbon, so a CH3 here. And now we can fill in the hydrogens. So butanol, the group positional functional group is positioned at the end of the molecule. 2-methyl, second carbon, a methyl group. That's it really. And now for this mechanism, what we use is hydrogen with a negative charge and a lone pair of electrons. And what's going to happen is it's going to attack the carbon and now transfer electrons to the oxygen. That's all it wants. It says first step. So read the question properly, because you don't want to just do all the steps and then realize it's pretty much a waste of time because it just wants the first step. And explain why NaBH4 reduces 2-methyl-butanol but has no reaction with 2-methyl-butanol. Well, if you think about it, the H- ion, the nucleophile, is attracted to the partially positive carbon. However, electron-rich carbon-carbon double bond, or the H- ion, okay, the nucleophile, is repelled by carbon-carbon double bond. So H- ion nucleophile is attracted to the partially positive carbon. That is true. That's why the mechanism happens, because it's attracted to partially positive carbon. However, with 2-methyl-butanol, it's got an electron-rich carbon double bond carbon, and the H- ion nucleophile is repelled by the carbon double bond carbon. And then it says a student 13.2, a student attempted to reduce a sample of 2-methyl-butanol but added insufficient NaBH4. The student confirmed the reduction was incomplete by using chemical tests. Give the reagent observation for the chemical test. So if we use Tollens reagent, and what would be the observation? A silver mirror. So 13.1, draw out 2-methyl-butanol at the end of the group to see the bond OH, and then the methyl on the second carbon. H- ion lone pair of electron attacks partially positive carbon, transfers electrons to the oxygen. Nucleophilic addition. I think this is a nucleophilic addition, I'm pretty sure. Yeah, and then the explanation, well, the H- ion nucleophile is attracted to the partially positive carbon-carbon double bond. However, electron-rich carbon double bond carbon with 2-methyl-butanol, well, the H- ion nucleophile is going to be repelled by the carbon double bond carbon. And in this one, Tollens region, the observation is silver mirror. And that is the end of question 13.